apply operations on vectors, applications to right triangles and oblique triangles. So in problem solving, there is really no specific procedure for that, but I can give you some tips on how we can analyze the problem and eventually solve it. So there is a ferry which departs from Cedar Island in North Carolina and travels to Ocracoke and is 10 miles north and 17 miles east from the point of departure. Now we're asked to use a vector to represent the path of the ferry and determine how far it traveled. So the first thing we do is to draw the problem, because by then we can visualize how it looks like. So there is a ferry here coming from the Cedar Island, and it aimed to travel to Ocracoke. Now, from the point of departure, this ferry is 10 miles north, 10 miles going north, and then it's also like 17 miles going east. So from the point of departure, this is 10, and then to the east direction is 17. So this is north and this is east. Okay? Now, our problem asks us to also find the distance it traveled from the point of departure to Ocracoke. So, we're trying to find this distance. Now, notice that we are creating a parallelogram, so it means that it prompts us to add vectors in order for us to find the path of the ferry. Okay, so this 17 here is also the same as I will draw it from here. That's also 17. Okay, this is also 10. Okay, but our figure is going from this direction. That would be from northeast direction. That's our vector. Okay, so this is our angle if we're going to, if this problem asks us the direction, but it does not. So what it wants us to solve is to find its path. Okay, path means the coordinates where your point, your ferry started and where it ended. So it means the path is the vector that is created to this point. Okay, which is also the sum of these two vectors. So if you're going to illustrate its coordinates, it's actually 17 and 10, but how do we illustrate the sum? This is a parallelogram. If you remember, when we're adding vectors, we are creating a parallelogram, and the sum is supposed to be the coordinates of the endpoint of this diagonal apart from 0. So therefore, we need to find this vector here, and the vector here is, we don't move to the left and right, so your x is 0 and your y is 10. The vector here, which is also the same as the vector here, supposedly it is 17 and 0 because it did not move from north and south. It only moves to the east. So therefore, your y value is 0, which is also the same here. Now, why is it necessary for us to illustrate our vector here? Remember, the path of the ferry is coming from the northeast direction. Okay? So therefore, we need to find the vector here instead of using this. Okay? So this is the figure that we are looking for. But of course, it's the same as here. Now, this is not a proper triangle that we need to manipulate in order to find the distance, because this is not the point of departure. This is the east direction already from the point of departure. So the proper way of writing the problem and illustrating it is using this triangle in the northeast direction. Okay? So therefore, if we will illustrate the sum of the vectors, all right, it will be equivalent to 0, 10 plus 17, 0. So our resulting vector of the sum, it's not the resultant, but the resulting vector of the sum is equivalent to 17 and 10. Because remember the algebraic method, and this is the parallelogram method. So the algebraic method is 0 plus 17 is 17, and 10 plus 0 is 10. Now, let's solve for the distance it traveled from the point of departure to its terminal at Ocracoke. So, we do that because we have a right triangle here. We can make use of the Pythagorean theorem. So, therefore, the distance it traveled is equivalent to the square root of x squared plus y squared. And our x is 17 and our y is 10. So that's square root of 17 square plus 10 square. We will use this because that is the resultant. So therefore, using our calculator, so that is the square root of 17 square plus 10 square. Okay, which is equivalent to 19.72. So therefore, the ferry had traveled 19.72 miles, and the path of the travel is the vector 17, 10. Now, this is really a simple problem on Pythagorean theorem, but of course, we need to do it technically because that is what is being asked of the problem. We have to solve it technically using vectors. And that's it.